Now, if you studied the red and the blue line, what would you say is similar about these two? Maybe pause the video. So hopefully you realise they are a mirror image of each other. So if I add in the line y equals x, you can see that they are mirrored exactly either side of this green line. So we say that the red function is an inverse of the blue function. Now, in the exam, you don't need to understand how to get from the red function to the blue function in terms of changing the equation. However, what you have to understand is the properties associated with both. For example, in your exam, you might be just given the red line. And using the red line, first of all, you have to draw the green line to help you draw an inverse function. So to draw the inverse function, you get a mark generally for the overall shape. But what you get most of your marks for is by being able to replicate approximately 3 or 4 points. So what you need to do is pick 3 or 4 points on the original function and replicate them for the new function and draw a line or a curve as required. We can see an axis between 1 and 10 between here and here, and if we zoom out a bit we can see a little bit more. So let's go for it now. Screenshotting this area, what we're going to do is we're going to select a point. We're going to select this point and I'm going to label this as 0, 3. Now to find the inverse function, all you have to do is switch these two numbers round. So let's find this point here. This point on the graph is going to be 3, 0. So we say that this is a point which is related to the point on the original function. Let's go for another point. This is going to be 1, 5. So to find the corresponding point on the next one, all we're going to do is switch the numbers around and we're going to take 5, 1. This will work for any kind of function, whether it's a straight line, cubic, linear model, or a logarithmic, for example. Then you just have to draw a straight line, not like this, joining these points together and making sure you're giving the impression that this straight line goes on forever, because straight lines, unless specified, can have an infinite domain and range. One-to-one and many-to-one, these are both functions. This is what the course is going to be focused on. And one-to-many is not a function. Now, like coordinates, the first word represents the x coordinates and the second one represents the y. So a really good example of a one-to-one function would be a straight line. And this is because for every x value, we have one y value. Let me show you what I mean by this. Let's get rid of these and let's add a table. So let's say we have 2, 3, 4, 5, 6 and we have 3, 4, 5, 6, 7. We join this with a straight line. You can see is indeed a one-to-one function because we have for every x value we have exactly one y value. Now let's have a look at a different example. Inserting this table, we are going to have the following: a range of different x values between -3 and we're going to have up to a maximum of 3. So starting with the smallest number this time, we're going to have a range of 7 values. Now let's say my function looked like this: 941 Now this is a typical function you might recognise. Please pause the video and have a think about what this function is. If we join this with a line, you'll be able to see that this is a quadratic function. Looking at the quadratic function, we are going to have what we expect from a quadratic function, which is a minimum or maximum and an axis of symmetry and a symmetrical pattern either side of the minimum. And this means that for every x value we have these different y values, but many x values, for example, -3 and 3, can map to the same y values. So we call this many to one. Now in the exam, you have got to be aware about substitution. This is relatively straightforward. If you have f of x equals 9x minus 5 and you want to find out what f of 5 means, this simply means wherever there is an x, like there is here, we are just going to replace it with 5. So this is just a simple substitution process. Similarly, on these questions here, they're a bit different. Pause the video and have a think about why the silver questions are different. Welcome back. Hopefully you realise that we're going to be replacing the whole of f of x with 12. So for this particular question, rather than replacing x with 12, we're replacing f of x with 12. So this is going to be replaced with the 12. So we would have 12 is equal to the fraction which is given on the right hand side, 5x minus 6, all divided by 2. Now you can use basic algebra skills to solve this, or alternatively you can actually type this into your calculator. So going on to the y equals, we're going to press clear on y1, clear on y2. We're then going to type in this equation, 5x minus 6 all divided by 2. Now, because this is a fraction, we need to make sure we include the brackets like I have written down. So the first thing we're going to do is we're going to put brackets, 5x, remember for any variable we're going to press this button to the right of alpha, minus 6. Now as before we're going to use this minus sign, and then we're going to close the brackets, and then we're going to press divide by 2. Let's just check we've typed in the correct thing. Yes, they look comparable. Now we would like to see the table. You can use the table or the graph, but the table is going to be the easiest. Second table. And what we're looking for is when f of x, which in this instance is going to be y, f of x is always going to be representative of y if we're thinking about a graph, when f of x is 12. Now, at the moment we can see that y is getting increasingly bigger as we go down the screen, so we need to go up the screen. You can see we have an issue here. So go on to the left hand side and continue pressing up. If this doesn't work, you need to change the window, or you need to change the table set. So the window actually affects what the graph itself looks like, what we can see from the minimum, maximum y values, minimum, maximum x values, but the table set gets us to start the table at a smaller value. Normally, we want the table start to be at, say, 1, and we normally want the jumps to go up in 1. Obviously, there's exceptions. So if we go back to the table, this should have adjusted without us glancing and scrolling up. Excellent. So when we have x is 1, so when x is substituted for 1 in this equation, we get the answer of minus 0.5. So we want to see when this blue column is going to equal 12, and we've got it here. So when x is 6, y1 is 12. Now, if we were to go back to the other question, let's go back to the bronze questions. Because these are different, so let's have a look at this question 2 on the left-hand side. 8x plus 4. So we go back to the y equals, press clear. We're going to type in 8x plus 4. Now, this question is going to be very different, and the reason why is because instead of replacing the f of x or searching the table for the f of x, we're going to search in the table for the x value. So we just need to press second table again. We've already changed the table sets, and we're just going to look when x is equal to 6. So we're going to scroll down, and x is equal to 6 when y is 52. So our answer for this question is going to be 52. Now there's one final skill I'd like to go over on my whistle-stop tour of functions. The final skill I'd like to go over is about inverse functions. Now we may have talked about briefly how to find an inverse function, but what's equally important is something called the domain and the range. The domain and the range are really significant for both the functions themselves given in the question and if you're requested to find the inverse function. So if you were to do it from a picture, which is quite an easy way to do it, the domain is simply going to be all of the x values that satisfy this graph. Now for the range, we're going to say all of the y values that satisfy this graph. So let's have a look. For this particular graph, we can see the x ranges between 1 and 3, and it's going to include 1 and 3 because the circles are coloured in. So we're going to have 1x and we are going to have a number 3. So x varies between 1 and 3. Now if we have a look at the y values, it's going to be similar. Because these circles are coloured in, we're going to have the inequality sign with the line underneath. Last but not least, we would like to talk about, well, how would we find the domain and range of functions if they are inverses of each other? Well, there's a couple of ways of doing this. And with the visual graph, this is quite easy. So all you do is you take the domain and range of the original function, and we need to manipulate it to find the domain and range of the inverse. So remember, the inverse is just something that is a mirror image in this line, which is the y equals x line. So all you need to do is you take the numbers and you switch them. Last but not least, we have got to remember that domain is to do with an x and range is to do with the y. So we've just got to then switch the letters. And you can see this because if we were to plot on the graph what the domain and range was for this particular graph, we would get the following. Going on to our slideshow, we're going to plot a few points. So the first point we're going to plot is, instead of 1 minus 3, we're going to switch the numbers round. So it's going to be minus 3, 1. So our first point is going to be here. Now let's have a look at another point. Let's now map out this point. This point in the original graph is going to be 2 minus 1. So we're going to switch that round. We're going to go minus 1, 2. Last but not least, let's plot this point. This point's going to be 3, 1. Let's switch those points around. So this time we're going to have 1, 3. Now you need to make sure you have a similar image of reflection. So you can see that when we start at this point here, to get to the next point, it goes slightly outwards first from the line. So this is at a greater distance. And then it goes back in again. So to get to this one, we need to go slightly out from the line and then go back in. Then we need to analyse, well, what's happening here? Well, this goes from this distance from the line and then it gets slightly closer to the blue line. So with this, we need to make sure we go slightly closer and then back out. Obviously, this is not an ideal picture. And let's see if this matches our domain and range. Our domain, let's have a look. Our domain for this particular function is going to be all the x values. Indeed, it is between minus 3 and 1. And our range is the y values it varies between. And indeed, it's between 1 and 3. Last but not least, let's talk about how we could do this on a graphing calculator if we were given a particular function. Let's go for a little bit more of a challenging function in terms of the equation, which is the square root of x plus 7 over 2. So getting the calculator out, we are going to go on to the y equals. We're going to press clear. We're then going to enter in our square root. You can function underneath the square root. So watch how I will do this. We're going to press the x here, then we're going to press the plus 7, then divide by 2. However, because we're dealing with a fraction, we need to make sure we have the relevant things. So we need to include the brackets first of all, x, and then we're going to put plus 7 in brackets because these are two terms on the numerator of a fraction, and then we're going to press divide by 2. The first thing I would have a look at is the graph itself. Now, the graph itself, you can see that this graph is going to continue in this kind of pattern. It's going to keep going on to infinity in terms of the x and the y axes. And if we change the x max to a much bigger number and the y max to a much bigger number, for example, we could use this doing the E button. So let's change it to an infinite number, 1 second. Press the divide sign and then 99. So this is 1 times 10 to the power of 99. So this is tending towards infinity, although obviously it's not going to be infinity because that's not an exact number. We can see it's just going to keep going on and on. So if we go back to thinking about the domain and range, we can use the infinity symbol. So if we are inserting an equation, we are going to have a look at infinity. So the domain is going to have something to do with infinity, and the range is going to have something to do with infinity. However, we can see if we're looking at the graph, there is a minimum and another minimum value of both x and y, and we need to work out, well, what are these values for x and y? And you will often find with these functions, at one end they'll continue on to infinity, and at the other end there will be a minimum, or if it was the opposite way around, a maximum value. The best way of working this out would be to have a look at the table. So press the second graph and have a look at the table. Now we can see at certain points we get errors. And the errors we get are as follows. We can see that the smallest possible x value is -7 and the smallest possible y value is 0. So let's substitute these in. -7 and 0. And the reason why is because when we have a square root, we have to generate a number which is bigger or equal to 0 for the square root. And for this to work, we would have at a minimum x to be -7, as this is the inverse of +7. The reason why this would be the case is because if we substituted in -7 into this equation, we are going to get the following. -7 plus 7 is 0, so anything which is 0 divided by any other number such as 2, 4, 5, 6 or a million, 0 divided by anything is always going to give you 0. So the square root of 0 is going to be 0. And this is just a rule that you need to learn. For the IB courses, for standard maths, the square root must be positive, but actually this reasoning you do not need to know. All you need to do is go onto the table, see where there's an error, and you can see that the minimum value for x is -7, the minimum value for y is 0. So you're using both the table and your intuition of what the graph looks like. So, as before, domain is to do with x and the range is to do with y. Similarly, we're going to say that y is smaller than or equal to 0.